Pervenets. The birth of the Russian armored fleet. Prologue. An era of change. September 1864. The Gulf of Finland.
Yes, Captain. The rivets
An
must be
unusual
precise.
silhouette
Good.
cuts
Proceed
through
with
the gray
inspection.
waters of the Baltic, low, squat, devoid of the elegant lines of sailing frigates. It is the Pervenets, Firstborn, the first seagoing armored ship of the Russian fleet, returning from sea trials. On board are the hopes of an empire striving to overcome the humiliation of the Crimean War. Iron plates, shielding a wooden hull, gleam in the autumn sun. Gun muzzles peer out through the portholes. A pioneering ship, a symbol, the vessel that opened a new era in the history of the Russian Navy. The sea has always been both a challenge and an opportunity for Russia. Peter the Great's reforms, the creation of a regular navy, the victories at Gangut and Chesme, all became part of the national mythology. But the Crimean War of 1853 to 1856 laid bare a painful truth. The Russian fleet was technologically behind the leading maritime powers. Wooden sailing ships of the line, once considered the pinnacle of shipbuilding, proved helpless against armored batteries and rifled artillery. It was at this moment of historical turning point that the Pervenets appeared, not just a ship, but a concept materialized in iron and wood. Its creation was a response to the challenge of the times, an attempt to catch up with progress and lay the foundations for the fleet of the future. Chapter 1. The wounds of Crimea and the search for a path. The Crimean War left deep scars not only on the map of the empire, but also in the minds of its rulers. The Treaty of Paris, 1856, which prohibited Russia from maintaining a military fleet in the Black Sea, was perceived as a national humiliation. But beyond the political restrictions, the war demonstrated a catastrophic technological lag. The technological breakthrough of the adversaries, French floating batteries, devastation, lave, and tonnante with iron armor. The effectiveness of Pétion's guns, shell-firing guns, against wooden ships. The superiority of steam engines over sail power. The Naval Ministry understood well. The traditional path of fleet development was exhausted. Radical solutions were needed. Grand Duke Konstantin Nikolaevich, the Admiral General heading the Naval Department, became the initiator of deep reforms. Under his leadership, a plan for fleet modernization was developed, with the creation of armored ships at its core. However, Russia faced a fundamental problem here, a complete lack of experience in building ironclads. Domestic shipyards had neither the equipment nor the specialists to work with iron armor. Wooden shipbuilding, in which Russian masters had achieved significant success, proved useless in creating fundamentally new ships. The solution was found in a compromise. It was decided to order the first ironclad abroad while simultaneously preparing domestic shipyards to master new technologies. The choice fell on Great Britain, a country at the peak of the Industrial Revolution, which already had considerable experience in building ironclads. Chapter 2. The diplomacy of iron and steam. The decision to order an ironclad in England was not only a technical move, but also a diplomatic gesture. Just a few years earlier, these countries had been adversaries in the Crimean War. Now, the Russian government was willing to pay British industrialists for technologies that could be used against whom exactly? Reasons for choosing British shipyards, technological leadership. By the 1860s, England already possessed several ironclads, including the famous Warrior. Industrial capacity, a developed metallurgical industry capable of producing high-quality armor. Shipbuilding experience. Shipyards on the Thames and elsewhere had the necessary equipment. Commercial calculation. British industrialists were willing to work with any customer. In early 1863, A Russian delegation headed by Captain First Rank Ivan Fyodorovich Likhachev arrived in London. He was tasked not only with concluding a contract for the ship's construction, but also with forming a group of Russian engineers and craftsmen who would learn the new technologies. The negotiations proved difficult. The British Admiralty, although unable to officially ban private shipyards from working with Russia, created various obstacles. However, commercial interests prevailed. A contract was signed with the Thames Ironworks and Shipbuilding Company in Blackwall. The terms of the contract were unprecedented. Construction cost, 1.2 million silver rubles. Construction time, 18 months. The right for Russian specialists to be present at all stages of work. The shipyard's obligation to train Russian masters. Transfer of all blueprints and technical documentation. A special commission was created to supervise the construction, consisting of Captain First Rank I.F. Likhachev, Chairman, Naval Engineer Colonel N.A. Artseulov, Engineer Mechanic Lieutenant Colonel A.I. Sokolov, several junior officers and craftsmen. This group became the first generation of Russian specialists in ironclad shipbuilding, men who would not only supervise the construction of the Pervenets, but also become teachers for subsequent generations of shipbuilders. Chapter 3. The birth of the Pervenets, the slipways of Blackwall. March 1863. The shipyard on the Thames. The sound of hammers, the hiss of steam, the smell of hot metal. On the slipway, the frames of the future ship begin to take shape. Russian officers in unfamiliar civilian clothes watch every stage of the work closely, making notes in thick notebooks. They are learning what does not exist in Russia. The concept of a floating battery. The Pervenets was built not as a classic ship of the line, but as a coastal defense floating battery. This concept was chosen for several reasons. Limited tasks, defending the sea approaches to the capital, Kronstadt and St. Petersburg. Technical simplicity, compared to full-fledged ocean-going ironclads. Cost savings, lower construction and operating costs. Rapid commissioning. An important factor given the technological lag. The project was developed jointly by Russian and British engineers. On the Russian side, N.A. Artseulov played the main role. On the British side, it was the shipyard's chief designer, John Kennedy. Main stages of construction. April to July 1863. Laying the keel and installing frames. Forming the wooden hull from English oak. Special attention was paid to the structural strength. The ship had to withstand not only enemy shells, but also the weight of the heavy armor. August to December 1863. Installation of the steam engine and boilers. Fitting of internal equipment. Start of armor plating work. January to May 1864. Installation of armor plates, artillery mounting, finishing work. Technical innovations. Combined construction. Wooden hull with iron armor. A compromise between strength, cost, and construction speed. Armor system. 114 millimeters thick plates, attached to a wooden backing. Artillery armament, 26 guns of various calibers, located on the battery deck. Screw sail propulsion system, a combination of a steam engine and sail rigging. Special attention was paid to training Russian specialists. Every day, officers and craftsmen were present at the works, studying not only the technologies, but also the organization of labor. In the evenings, they gathered in a rented house near the shipyard to discuss what they had seen and plan how to apply the acquired knowledge in Russia. Chapter 4. Anatomy of the Firstborn. A technical portrait. Main. Characteristics. Hull. Displacement, 3,277 tons. Other sources state 3,200 tons. Length, 67.2 meters. Beam, 16.2 meters. Draft, 4.9 meters. Hull. Material, Oak with copper sheathing on the underwater part. Armor. Armor belt. Thickness 114 millimeters, 4.5 inches. Armor belt. Height 2.1 meters. Armor deck 25 millimeters. Armor weight approximately 800 tons. Fastening system. Bolted connection through a wooden backing power plant. Type: one horizontal direct-acting steam engine. Power: 1,067 indicated horsepower, 786 kilowatts. Boilers: 4 rectangular fire tube boilers. Coal capacity: 300 tons propeller, 1 screw speed, 8.5 knots, on trials. Sail: rig: 3 masts with square rig armament. Upon commissioning: 26 guns, 20 by 60 pounder, 196 millimeters. Smoothbore guns, 6 by 24 pounder, 152 millimeters. Carronades. Ammunition: 100 rounds per gun. Aiming system. Manual mechanisms. Fields of fire. Limited by the battery deck construction. Crew: officers, 25 men. Enlisted, 480 men. Total, 505 men. Design features: low freeboard, only 1.2 meters. Reduced the target area but worsened seaworthiness. Battery deck: all guns were mounted along the sides in one enclosed deck. Conning tower: primitive, practically unprotected. Ventilation system: natural, insufficient for tropical latitudes. Living quarters: cramped, with minimal amenities. Comparison with contemporaries: French Gloire, 1859. Fully iron hull, speed 13 knots. British Warrior, 1860. Iron hull, speed 14 knots. Pervenets, wooden hull with armor, speed 8.5 knots. As the comparison shows, the Pervenets was not an advanced ship even at the time of its creation. However, its significance lay not in technical perfection, but in the fact that it was the first step, the first attempt, the first experience. Chapter 5. The Road Home. Trials and Hopes. June 1864. The mouth of the Thames. The Pervenets is ready for the passage to Russia. On board is a mixed crew, British sailors ensuring the passage and Russian officers just beginning to master the new ship. Captain First Rank Likhachev gives his final orders. Tomorrow, departure to sea. The passage from England to Russia was the first serious test for the ship and its crew. The route lay through the North Sea, the Kattegat Strait, and the Baltic Sea to Kronstadt. Chronicle of the passage, June 15, 1864. Departure from London. First problems: insufficient stability caused by the heavy, high-mounted armor. June 17th to 20th. Sailing in the North Sea. Stormy weather revealed shortcomings in seaworthiness. The low freeboard was swept by waves. June 22nd. Passage of the Kattegat. First artillery exercises. The gun's recoil caused strong hull vibration. June 25th. Entry into the Baltic Sea. Damage control drills. Problems with compartments were identified. June 30. Arrival in Kronstadt. Ceremonial welcome. Inspection of the ship by Emperor Alexander II. First impressions. The Emperor, inspecting the ship, remarked, Quote 2. These words accurately reflected the ambivalent attitude towards the Pervenets. On one hand, pride in the first success. On the other, an understanding of the ship's limited capabilities. Official trials. July to August 1864. Speed trials. Maximum speed 8.5 knots at engine power of 1,067 horsepower. Coal consumption 1.5 tons per hour. Artillery firings, testing the strength of the armor and the gun mounting system. Seaworthiness, test, limited ability to sail in rough weather. Survivability tests, flooding compartments, testing pumps. Commission conclusions, positive aspects, satisfactory seaworthiness for the Baltic Sea. Sufficient protection against existing artillery. reliability of mechanisms, good conditions for artillery service. Negative aspects: insufficient speed, high coal consumption, cramped living quarters, poor ventilation, limited fields of fire for the guns. Despite the shortcomings, on September 5, 1864, the Pervenets was officially accepted into the Baltic Fleet. It was included in the Practical Squadron, where it was to serve as a training ship for mastering new technologies. Chapter 6. Service in the Ranks, Years of Learning. The first years of the Pervenets' service were spent in intensive combat training. The ship became a floating laboratory where the tactics of armored warfare, command methods, and shipboard organization were developed. Main areas of activity: training cruises in the Gulf of Finland, artillery drills, developing firing methods for battery guns, maneuvers with other ships, practicing coordination, experiments with armor, studying the impact of shells, training specialists, educating officers and sailors, significant service events, 1865, first large-scale maneuvers involving the Pervenets. The ship operated as part of a detachment alongside wooden frigates. Problems of interaction between different ship types were identified. 1866, participation in a fleet review. Emperor Alexander II observed artillery firing. The Pervenets demonstrated good accuracy but a low rate of fire. 1867. Joint exercises with the newly built Russian armored frigate Sevastopol. The first experience of interaction between two armored ships of the Russian fleet. 1869. Maneuvers off Gogland Island. The Pervenets operated as part of a squadron alongside the armored battery, Kremlin, and screw frigates, practicing group battle tactics. Daily life on board. Life aboard the Pervenets was hard even by the standards of the time. Officers. 25 men were housed in cramped cabins in the stern. Senior officers had separate cabins of 6 to 8 square meters. Junior officers lived 2 to 3 to a cabin of 4 to 5 square meters. Sailors. 480 men were accommodated on the battery deck in hammocks. Population density, about 0.5 square meters per person. Food, standard naval ration, corned beef, hardtack, groats, vegetables, and fresh meat only at the beginning of a voyage. Hygiene. 1 wash per week. Ventilation problems led to the spread of disease. Discipline. Strict with the retention of traditional corporal punishment. Despite the harsh conditions, the Pervenets became a school for an entire generation of sailors. On board, hundreds of officers and sailors were trained, who would later serve on the new ironclads. Chapter 7. Domestic continuation. Neutron mania, touch me not. The successful experience of building and operating the Pervenets convinced the naval leadership of the possibility of creating ironclads at domestic shipyards. As early as 1864, even before the completion of the Pervenets trials, a decision was made to build a second floating battery based on its plans, but with the identified shortcomings addressed. The Neutron Mania Project, construction site, Street. Petersburg, Galerny Island Director, Naval Engineer N.A. Artseulov. Timeline, laid down in 1864, launched in 1865. Features: shortcomings of the Pervenets addressed, armor reinforced, ventilation improved. Comparative characteristics: feature Pervenets, 1864. Neutron Mania, 1865. Armor 114 millimeters, 127 millimeters, speed 8.5 knots, 9 knots. Armament 26 guns, 17 guns, but larger caliber. Displacement 3,277 tons, 3,500 tons. Significance of Neutron Mania. Proof of capability. Russian shipyards were able to build an ironclad. Accumulation of experience. A team of specialists was formed. Technological base. Equipment for working with armor was created. Educational effect. Personnel were trained for future projects. Following Natron Menya, a third floating battery, the Kremlin, 1867, was built. Thus, the Pervenets became the progenitor of a whole family of ships, and more importantly, the starting point for the development of domestic ironclad shipbuilding. Technology transfer. The officers and craftsmen who worked on the construction of the Pervenets in England became teachers and mentors. N.A. Artseulov supervised the construction of Natron Menya and Kremlin. A.I. Sokolov headed the mechanical department on the new ships. Junior officers became builders of subsequent ironclads. It was thanks to this first experience that Russia was able to overcome its technological lag relatively quickly, and by the 1870s was building ironclads that were not inferior to foreign analogs. Chapter 8. The Armored Squadron. Tactics and Strategy. By the end of the 1860s, the first Russian armored squadron was formed in the Baltic, consisting of Pervenets, floating battery, Natron Menya, floating battery, Kremlin, floating battery, Sevastopol, armored frigate, Petropavlovsk, armored frigate. This heterogeneous group of ships became a proving ground for developing armored fleet tactics, tactical problems and solutions, heterogeneity of ships. Floating batteries. Slow, with limited seaworthiness. Armored frigates. Faster, but weaker armored. Solution. Division into tactical groups by purpose. Fire coordination. Different calibers and gun systems. Fire control problems. Solution. Development of unified firing regulations. Squadron command and control. No radio, only visual signals. Difficulties in bad weather. Solution. Simplified signaling systems. The Pervenets' role in the squadron. As the oldest and slowest ship, the Pervenets usually took a position in the center or rear guard of the squadron. Its main tasks were defense, screening more valuable ships, fire support, using artillery at medium range, training functions, drilling crews from other ships, experimental, testing new tactical techniques, maneuvers of 1869, testing concepts. The most illustrative were the 1869 maneuvers off Gogland Island. The squadron of 5 ironclads and several auxiliary vessels practiced, forming a line ahead, column, redeploying into a line abreast, front, coordinated artillery firing, repelling attacks by torpedo boats, the new weapon of the time. The results of the maneuvers showed the effectiveness of ironclads in defense, the need for increased speed, the importance of a unified command system, the need for specialized ships of different classes. In these maneuvers, the Pervenets played the role of a floating fort, a stationary or slow-moving firing point. This role matched its capabilities, but it was already clear that the future belonged to faster, more seaworthy ships. Chapter 9. The Twilight of an Era. Obsolescence. The 1870s were a time of rapid development in naval technology. The appearance of rifled artillery, improvements in armor, the development of steam engines, all this quickly made the Pervenets obsolete. Technological changes, artillery, 1860s, smoothbore guns up to 200 millimeters caliber, 1870s, rifled guns up to 300 millimeters caliber, armor-piercing shells. Consequences. The Pervenets' armor, 114 millimeters, became vulnerable. Armor, 1860s, wrought iron, 1870s, compound armor, steel-faced iron. Consequences. New armor of the same thickness offered better protection. Power plants, 1860s, horizontal steam engines, efficiency 5 to 7%. 1870s, compound engines, efficiency 10 to 12%. Consequences. The Pervenets, with its 8.5 knots, became too slow. Ship design, 1860s, broadside ironclads with guns along the sides. 1870s. Turret ships with rotating gun mounts. Consequences. The Pervenets' limited fields of fire became a critical drawback. Modernizations of the Pervenets. In an attempt to prolong the ship's service, several modernizations were carried out in the 1870s. 1872, replacement of part of the artillery. 4 new 203mm rifled guns were installed. 1874, installation of anti-torpedo boat artillery. 10 small-caliber 87mm guns on sponsons for defense against torpedo boats. 1876, repair of mechanisms, replacement of worn parts of the steam engine. 1878, reinforcement of armor, addition of a 25mm armored deck. However, these measures could only slightly delay the inevitable. By the early 1880s, the Pervenets was so obsolete that its combat value was close to zero. Comparison with new ships. Feature Pervenets, 1864. Peter Veliky, 1877. Speed, 8.5 knots, 14 knots. Armor, 114mm iron, 356mm compound. Armament, 26 smoothbore guns, 4 times 305mm guns in turrets, design broadside turret Ironclad. The difference was so great that the Pervenets could not effectively engage not only new ironclads, but even some cruisers and gunboats. Chapter 10. The Last Years, From Combat to Training. By 1880, the Pervenets had finally lost its significance as a combat unit. However, they were in no hurry to remove it from the fleet. The symbolic value of Russia's first ironclad was too great. Change of status, 1881. Reclassified from a floating battery to a gunnery training ship. 1882. Withdrawn from the active squadron. Placed in reserve. 1883 to 1885. Used as a stationary training ship in Kronstadt. Training functions, gunnery training, teaching gunners how to handle guns. Engineering practice, studying the design of the steam engine and boilers. Navigation training, basics of navigation on a real ship. General shipboard service, studying the organization of life on board. Life on board in the 1880s. For cadets of the Naval School, service on the Pervenets was both honorable and arduous. Daily routine, reveille at 6 o'clock, drills until 1800, lights out at 2200. Practical exercises, working with mechanisms, handling sails, artillery drills. Theoretical training, studying blueprints, calculations, tactics. Living conditions, Spartan, but better than on active ships. The last cruise, 1886. The Pervenets makes its final training cruise in the Gulf of Finland. On board is the graduating class of the Naval School. The old ship, now missing most of its armament, slowly moves along a familiar route. For many cadets, this is their first and last voyage on the legendary ship. September 1886. The Pervenets returns to Kronstadt and is laid up. The decision for its final decommissioning has already been made. Chapter 11. Decommissioning and Subsequent Fate, Kronstadt Harbor. The Pervenets lies at the pier, gradually turning into a monument to itself. The paint is peeling, the mechanisms are rusty, but its silhouette still hints at the ship that once opened a new era. Decommissioning process, January 1887. A commission is formed to determine the ship's fate. Options: preservation as a museum, conversion into a block ship, floating barracks, scrapping for metal. February to March 1887. Technical condition survey. Conclusions: hull, heavily worn, requires major repairs. Mechanisms, completely obsolete, restoration impractical. Armor, well preserved but technologically outdated. Overall assessment: maintenance economically unviable. April 1887. Decision made to scrap the ship. Main reasons: high maintenance cost, lack of practical value, need to free up harbor space, value of materials, iron, copper, wood. Scrapping process. May to August 1887. Dismantling of armament and equipment. Removal of armor plates. Dismantling of mechanisms. Breaking up the wooden hull. September 1887, officially stricken from the fleet lists. Subsequent fate of materials. Armor plates, melted down, used for other purposes. Mechanisms, partially preserved as training aids. Wood, used for various purposes. Metal, melted down at shipyards, memory of the ship. Despite its physical disappearance, the Pervenets left a deep legacy. In shipbuilding, plans and technologies were used in the construction of subsequent ships. In education, operational experience became part of training programs. In culture, mentions in memoirs, articles, historical works. In traditions, the name Pervenets became a byword for the first ships of new classes. Chapter 12. Historical significance. Assessment through the years. Military, technical significance. First experience. The Pervenets was the first seagoing ironclad of the Russian fleet, proving the very possibility of creating such ships for Russia. Technological bridge. The ship served as a link between the traditional wooden sailing fleet and the new armored steam fleet. Educational effect. The first generation of Russian specialists in ironclad shipbuilding grew up through its construction and operation. Tactical laboratory. The Pervenets became a proving ground for developing armored warfare tactics, command methods, and shipboard organization. Comparative analysis with foreign analogs. In the context of global shipbuilding, Parameter Pervenets, Russia, 1864. Warrior, UK, 1860. Gloire, France, 1859. Displacement, 3,277 tons, 9,210 tons, 5,630 tons. Armor, 114 millimeters iron, 114 millimeters iron, 119 millimeters iron. Speed, 8.5 knots, 14 knots, 13 knots. Armament, 26 smoothbore, 40 guns, 36 guns. Construction wood, plus armor, iron hull. Cost 1.2 million rubles, approximately 2.5 million rubles, approximately 2 million rubles. Conclusions. The Pervenets was smaller, slower, and more weakly armed than the best foreign examples. However, it cost almost half as much. Its construction, wood plus armor, was a compromise, but allowed for quickly gaining initial experience. The main achievement was not technical perfection, but overcoming the psychological and technological barrier. Assessments of contemporaries and historians. Contemporaries, 1860s. Admiral G. W. Butakov, quote 5, Naval Engineer N.A. Artseulov, quote 6, Naval Minister N.K. Krabbe, quote 7, Historians, 20th to 21st centuries. R.M. Melnikov, quote 8, V. Ya Krestyaninov, quote 9, I. Chernikov, quote 10. Legacy in shipbuilding. Direct successors of the Pervenets can be considered. Neutron, Menya, and Kremlin, built to its plans. Sevastopol and Petropavlovsk, the first Russian armored frigates. Petr Veliki, the first Russian full-fledged seagoing ironclad, the entire line of Russian battleships up to the Russo-Japanese War. Chapter 13. The People of the Pervenets. Crew and commanders. Commanders of the ship, Captain First Rank Ivan Fyodorovich Likhachev, 1864 to 1865, supervised the ship's acceptance in England, commanded during the passage to Russia, organized the first trials, later admiral. Participant in the Russo-Turkish War, Captain First Rank Alexander Alexandrovich Popov, 1865 to 1867. Future creator of the, quote, 11 circular ironclads, led the first serious exercises, made improvements to shipboard organization, became one of Russia's leading shipbuilders. Captain First Rank Mikhail Pavlovich Manganari, 1867 to 1870, renowned hydrographer and cartographer, focused on training activities, organized systematic crew training. Later, head of the hydrographic department, Captain First Rank Fyodor Vasilyevich Dubasov, 1870 to 1873. Future hero of the Russo-Turkish War, participant in the Pacific Expedition, made improvements to tactical training. Later, Admiral Governor-General of Moscow, Captain Second Rank Nikolai Illarionovich Skridlov, 1873 to 1876, young promising officer, focused on technical training. Participated in the ship's modernization. Later, commander of the Black Sea Fleet, Officer Corps. During its years of service, over 200 officers trained on the Pervenets, including 15 future admirals, 30 future ship commanders, 20 future shipbuilders, 10 future scientists, hydrographers. Training features, technical literacy. Officers had to understand not only tactics, but also the design of machinery. Practical approach. Great attention was paid to real skills, not just theory. Interdisciplinarity. Officers studied artillery, mechanics, navigation, and shipbuilding. Mentorship. Senior officers actively trained juniors. Enlisted men. The crew of the Pervenets was formed from 60% conscripts into naval service, 25% civilian specialists, mechanics, stokers, 15% penalized sailors from other ships. Service conditions. Positive aspects. Regular meals, by the standards of the time. Medical care. Opportunity to learn literacy and trades, clear daily routine. Negative aspects. Heavy physical labor, strict discipline with corporal punishment, cramped and unsanitary conditions, high injury rate. Famous sailors of the Pervenets, Ivan Butakov, brother of Admiral Butakov. Later became a boatswain. Pyotr Schmidt, father of the legendary Lieutenant Schmidt, Vasily Kaidalov, later a well-known ship repairman. Impact of service on lives. For many officers and sailors, service on the Pervenets was formative, gaining unique experience, shaping a professional worldview, establishing connections and acquaintances, determining future career paths. Chapter 14, The Pervenets in Culture and Art, Literary Mentions, Memoirs of Participants. I.F. Likhachev, quote 12, N.A. Artseulov, quote 13 Sailors' Diaries, several copies preserved. Fiction, K.M. Stanukovich, mentions in Sea Stories. A.S. Novikov Pryboy, episodes in Tsushima, modern historical novels. Fine arts, contemporary depictions, watercolors by English and Russian artists, lithographs in magazines of the time, photographs, early experiments in marine photography. Models, 1:48 scale model created by the builders. Model in the Maritime Museum in St. Petersburg. Modern replicas for collectors. Photographic legacy. About 20 photographs of the Pervenets survive, taken in different years. 1864, acceptance trials in England. 1865, first exercises in the Gulf of Finland. 1870, after modernization. 1880, as a training ship. 1886, last photographs before scrapping. Press mentions, contemporary press, 1860s to 1880s. Morskoy Spornik, Naval Digest. Regular service reports. Kronstadtski Vestnik, Kronstadt Herald, notes on daily life. British newspapers, articles on construction and trials, scientific publications, technical reports on trials, articles on operational experience, comparative analyses with foreign ships. Cinematography. Although there are no direct films about the Pervenets, the ship is mentioned in documentary films about naval history, historical reenactments, educational programs. Modern reconstructions, computer models, 3D models created for research and education, virtual museums, interactive online exhibitions, historical reenactments, episodes and events by military historical clubs. Chapter 15. Lessons of the Pervenets. What the first experience taught. Technical lessons. Drawbacks of the combined construction. A wooden hull with iron armor proved to be a suboptimal solution. Importance of speed. 8.5 knots proved insufficient even for defensive tasks. Problems of the broadside scheme. Limited fields of fire reduced the effectiveness of the artillery. Significance of survivability. Insufficient subdivision into watertight compartments. Comfort issues. Poor ventilation and cramped conditions reduced the crew's combat effectiveness. Organizational lessons, personnel training, the importance of systematic training for specialists, technical documentation, the necessity of a clear system of blueprints and instructions, supply and logistics, problems with spare parts and materials, repair base, the necessity of creating specialized workshops. Tactical lessons, limitations of floating batteries, the necessity of creating ships of different classes, importance of speed and maneuverability, even for defensive tasks. Need for a unified command system, especially when coordinating heterogeneous types of ships. Significance of reconnaissance and communication. Without these, even a powerful ship is helpless. Economic lessons. Cost of new technologies. Ironclad shipbuilding proved to be significantly more expensive than traditional shipbuilding. Operating costs. High coal consumption, the need for qualified maintenance. Amortization, rapid obsolescence required constant modernizations. Efficiency of investments, the importance of long-term planning. Political lessons, dependence on foreign technologies, the necessity of developing one's own industry. Diplomatic aspects, the difficulties of cooperating with recent adversaries. Public perception, the importance of promoting successes to maintain prestige. International competition, the need to consider the development of other countries' fleets. Application of lessons in the future. The lessons drawn from the experience of the Pervenets were used in the construction of subsequent ironclad ships, the development of shipbuilding programs, the creation of a personnel training system, the formation of the doctrine for fleet deployment. Final thoughts. The Pervenets was more than just a ship. It was a symbol of Russia's striving for progress, a symbol of overcoming backwardness, a symbol of faith in its own strength. Its modest technical specifications should not overshadow the main thing. It existed, and its existence paved the way for all subsequent development of the Russian armored fleet. In the history of every nation, there are such firsts, imperfect, modest, but necessary. They are like a child's first steps, uncertain, but leading to the ability to walk. The Pervenets was such a first step for Russia into the era of armor and steam, and like any first step, it deserves to be remembered and respected.